So you are plugging negative x in for x squared plus 2x plus 1. And then the second thing that you're going to do is you're going to take x plus 2 and you're going to plug that in for everywhere that you have an x. And I'm going to give you 3 minutes. You may not finish both of them in 3 minutes, but that's okay. 3 minutes. Easiest thing to do when you're talking about interval notation is to draw a number line. Okay, so we're going to draw a number line right here. Okay, here is 2 and here is negative 2. So here is positive 2 right here, and here is negative 2. 2 and negative 2. Okay, now I can put any of these values in, and I'm going to get something that's defined. I'm allowed to put any of those numbers in. I'm also allowed to put any of these numbers in. Those are the numbers in between negative 2 and 2. Then I'm allowed to put all these numbers that are greater than 2 in. Okay? To write that in interval notation, and I don't think we've talked about interval notation in this class, okay? But to write this in interval notation, we start way down there at negative infinity, okay? And negative infinity is right here. It's at the end of this line. So writing this in interval notation, I say, okay, negative infinity, and I go all the way to negative 2. Okay? What means or union? What sign does? The U. Good. Okay? Now, what students want to do next is they want to jump to the positive 2. That's what they want to do next. They want to say, oh, I know how to do this. Then it's 2 to infinity. But what happens is students forget about this part in the middle. So I've got to write in interval notation, I've got to represent all the numbers between negative 2 and 2, but not negative 2 and 2. And so I do that by what looks like an ordered pair. It looks like an ordered pair. It's not an ordered pair. Now, I'm going to write that at the top again because I see lots of people straining to see that, okay? So I'm going to write that again at the top. So I start at negative infinity, and I go all the way to negative 2. Negative 2 is not included, so that's why I have the parentheses. What's the symbol for if it was included? What do I have to have if it is included? Parentheses mean the number is not included. A bracket. Good. That's what it is. It's a bracket. Good. Okay, then I'm saying or, so I'm saying any number between negative infinity and negative 2, or any number in between negative 2 to positive 2, or any number from 2 to infinity. The parentheses are telling me that 2 and negative 2 are not included. Because if I put 2 or negative 2 into x squared minus 4, what am I going to get? 0. So x cannot be 2 or negative 2 because I get something that is undefined when I do that. Okay? So one of the things that you look for when you are defining the domain of a function is you ask yourself, is there a variable in the denominator? And if there is a variable in the denominator, you have to limit the domain. And that's what I've done here is I've limited the domain. Okay? Can we go to the next one? Yeah, that's not what I wanted to do. Okay. Here's the next situation where you limit a domain. The next situation that you limit the domain is when you have a variable inside a square root is the most famous, but you've got to think about limiting the domain anytime you've got a variable in a radical sign, okay? So, square root is our most common, but you're really limiting your domain anytime that you have a variable inside a radical. That's when you're thinking about it. Now, there's times that you've got a variable inside a radical that you wouldn't have to limit the domain. But if you've got a radical, you need to pay attention because you might need to. Now, I want to stay in the set of real numbers. I don't want to talk about I, and I don't want to talk about anything in the imaginary field. So if I'm staying in the square root of real numbers, can I take the square root of negative 4? No. Okay? The square root of negative 4 is undefined when we are talking about real numbers. Now, we talked some about how you can have imaginary numbers or complex numbers. We're not talking about that set of numbers. We're only talking about real. So in this situation, you want to keep anything that is inside that square root, you want to keep it above 0. Okay? Now, can I take the square root of 0? Yes, I can take the square root of 0. The square root of 0 is 0. So it's okay if x is 0. It just can't be less than 0. So it's important because on our screen before, we couldn't have 0. We could have negative numbers, but we couldn't have 0. Okay? Here, we can have 0, but we can't have any negative numbers. So you've got to have that or equal to sign. Okay? Let's solve one of these. Okay. I want to do D, just to make sure that we don't run out of time, because we always run out of time. So I want to do D. So that's what we're doing right now is D. Okay? So I've got to look at that 4 minus 3x. 4 minus 3x. And it's got to be, so 4 minus 3x has got to be greater than or equal to 0. 4 minus 3x has got to be greater than or equal to 0. And we know how to solve this. We subtract 4 from both sides. What's dangerous? What might we drop? The negative. Don't drop the negative. That's a mistake lots of students make. Don't drop the negative. So then I'm going to have negative 3x is greater than or equal to negative 4. When I divide both sides by negative 3, what happens? I do get a fraction. What do I have to do with my inequality sign? I flip it. I reverse it. You reverse your inequality sign when you multiply or divide both sides by a negative. And I did here. So now the domain of this is x is less than or equal to 4/3. So I'm going to draw a number line. Okay. 4/3 is slightly more than 1. 4/3 and 1 1/3 is the same thing. I'm going to put a bracket there because it's included. It is helpful to draw the number line. It's very, very helpful to draw the number line. So my domain of this is negative infinity up to and including 4/3. That's my domain. And that's so what you're looking for, this is the answer that you're looking for. That is your domain in interval notation. Yes, ma'am?
And you put the sign when?
Anytime that you multiply or divide by a negative number. So it's this number right here that makes me do that. This number right here. Okay? So when you multiply or divide by a negative number. So the -4 doesn't matter. It's the one that you're dividing both sides by. That's the one that matters. Good question. So this is it right here, guys. When you multiply or divide both sides by a negative number, that's when you reverse. Flip is the non-mathematical term. You reverse the inequality sign. Okay? Can I go to the next screen? Okay. Well, now, I'm hoping that we can see this okay. Now we're going to talk about a lot of those things that we just did, but we're going to do it looking at a graph, okay? This isn't algebraic. This is a graph. We're going to find the domain, we're going to find the range, and we're going to find some values based on this graph. Now, what I do very often when I am looking at a graph is I write down some of the points. So look right here. Do you see how this point right here is -1, 1? Do you see that? That's the beginning of my graph. Do you see how that point is colored in? It's solid. That means that point is included. Okay? Now here, there's the end of my graph right there where it says 5, 2. That point 5, 2. For me to find the domain and for me to find the range of this function, I need to know where this graph begins and where this graph ends. Like I said earlier, a lot of times where your graph begins and where your graph ends is negative infinity to infinity. But in this situation, we have a very distinct beginning point and a very distinct end point because we're looking at a graph. Okay? Now, once I have identified these 2 points where my graph begins and ends, it's easier for me to think about domain and range. So if I think about this -1, 1 as an x and y value, and I think about this 5, 2 as an x and y value, it is much, much easier to identify domain and range because domain focuses on which of those values, x or y. X. And what does the range focus on? Y. Okay, now, the fact that this point is solid and this point is open, that matters, okay? It matters. It matters that that point's open and the other point's closed. So, my x values, I start with -1 because I'm always going from the left to the right. So the domain of this starts with -1, and I'm going to have a bracket there because that dot is closed. Then on my far point to the right, what is the x value of my far point to the right? What's the x value of that point? This point right here is the one I'm talking about. What's the x value there? 5. Okay? Now, I'm going to have a parenthesis there because that point is not included. And how do I know it's not included? Because it's open. So I'm going to put point not included because open. Okay, so that point is not included because it's open. Now, when I'm talking about the range, I want to look at my y values. So I'm still looking at this point and I'm still looking at this point, but I'm only looking at my y values. Okay? No, never mind. I said that wrong. Okay. Now, for my y values, I want to look at my highest and my lowest point. Okay, so that's the points that I'm looking at for my highest and my lowest point. Do you see how this 0, 3 is my highest point? And do you see how 2, negative 3 is my lowest point? Okay, that's going to be my range, but I'm only looking at my y values in those 2 points. What is my lowest y value in those 2 points that I have highlighted? What's my lowest y value? Good. And is negative 3 included or not included? It's included, so I'm going to have a bracket. And how high do I go? Up to 3. Is 3 included or not included? Included. Okay? So the thing that you've got to focus on with your x values is you're only looking at that x. For domain, you're looking at your x. And for range, you're looking at your y. Write those points down. Make and highlight them. And remind yourself that range is my y values, domain is my x. Okay, now part B is different because you're not plugging negative 1 into a formula. You're taking negative 1 and you're seeing where it falls on the graph. So negative 1, f of negative 1, we are talking about the x value of negative 1. So I go on my x axis. There's negative 1. Nope, that's positive 1. Okay. Here's negative 1 on my x-axis. What's the value of y when x is at negative 1? 1. Okay, so f of negative 1 for part B equals 1 because that's my y value. Okay, what about f of 2? Here's f of 2, or there's where 2 is on my x-axis. What's my y value when x is 2? Negative 3. Good job, guys. There we go. Sometimes students are more comfortable with the algebraic or the equations, and sometimes the graph kind of confuses them. Okay? And that's okay. But kind of keep that in mind. Can I go to the next screen? Okay. The vertical line test. That's probably one of the things that students remember the most about high school is dragging a pencil or a vertical line across a graph. If a graph passes the vertical line test, then it's a function. It's a function. So this graph right here, I could drag it across, right? I could. So this is a function. Okay, something that's not a function. Okay, so if I had this right here is not a function. And the reason it's not a function is because I could not drag my vertical line across it. So it would not be a function. Okay, something else that's not a function . That's not a function. Okay, because I can't drag the vertical line across it. Now, what about this? Is that a function? Yes, it is. Okay, it's a cubic, so it is a function. Okay? So the vertical line test. In general, I have found that students don't struggle with that so much. Now, zeros of a function. This completely drives a ton of what we do in this class. Zeros of a function. When I am talking about zeros of a function, I am talking about where the graph crosses the x-axis. Where the graph crosses the x-axis. Okay? That's what I'm talking about. X-intercepts. X-intercepts. I write really big. Okay, x-intercepts. Where y is equal to 0. That's what a zero of a function is. Something else you might hear it called, but it's very rarely, I don't ever say it. You might hear the word roots, the roots of a function. Most of the time you're going to hear it called zero, the zeros of the function, okay? The zeros of the function is not the y-intercept. Now, when we graph lines, we focus a ton on the y-intercept, but we don't when we're doing other types of functions. Other types of functions, we will mention the y-intercept, but most of everything that drives us is the x-intercepts. And when I talk about a solution, find the solutions of a graph, we're talking about where it crosses the x-intercepts. Okay? So, one of the big ways that you do this is you set your function equal to 0. You set y equal to 0. That's how you find your x-intercepts. And we're going to do a bunch of these. Okay? Are we ready? Can I move to the next? Okay. So we're going to do all three of these. 3x squared plus x minus 10. We're going to do g of x equals square root of 10 minus x squared. And then we're going to do 2t minus 3 over t plus 3. I want us to look at the graphs of these. If you have Desmos, that is a nice graphing tool for you to use. There will be a portion of your test where you use Desmos on your test. So you don't have to have a fancy calculator. It may be a take-home part or something, but you will do some graphing. So be sure that at some point you download Desmos, Desmos. You can also go to www.desmos.com. Okay, but it's a nice little app that we're going to be using some in the semester. So our first one that we're going to do was, and this is already showing you the graph. It's f of x. We're trying to find the zeros of this. Is 3x squared plus x minus 10. And we can look at this graphically and we can see, here it is, right here. We cross at -2 and we cross at 5 over 3. Do you see how the y values are 0 on both of these? Okay, that's what we're talking about. Now, in order to solve this one, I have to factor. I have to factor this. And I know that we don't love factoring. So if factoring is not your thing, you let me know and I'll send you some videos that can help with that. So I'm going to set this equal to 0. So I've got 0 equals 3x squared plus x minus 10. Now, my a value here, which is my coefficient in front of my x squared, is 3. So in order to solve this, what I have to do is I have to factor using the AX method. So I take my 3, I multiply it times my negative 10. So my product is going to be negative 30. And my sum is going to be 1. I get my sum from this value right here. My product is 3 times negative 10, but my sum is whatever's in front of that x. Now, the two numbers that multiply together that give me negative 30 and added together that give me positive 1 are 6 and negative 5. 6 and negative 5. So now what I do is I rewrite this as 3x squared plus 6x minus 5x minus 10. 3x goes into the first two. I'm left with x plus 2. Negative 5 go in the second two. And I'm left with x plus 2. Okay. Now, factoring is one of those skills that we assume you know before you come into 144. So if you don't know how to factor, that's something that you need to practice, because you will not be successful in 144 if you don't know how to factor. Okay? So now that I have my two factors, I set each one up equal to 0. So I have 3x minus 5 equals 0, and x plus 2 equals 0. Okay? So x equals negative 2, or x equals 5 over 3. So this is how I solved it algebraically. I solved this algebraically, and my answers are negative 2 and 5 over 3. Those are the solutions. This is what it looks like graphically. That's what it looks like graphically. Okay, now I'm going to pause. From 0 to 5, tell me how comfortable you are with factoring. So if you looked at this and you thought I was speaking another language, you're going to be a 0. If you looked at this and you were like, I remember something about it, but that particular problem, I couldn't remember to multiply the A and the C, then you're probably a 3. If you were like, hey, I'd done it, you're a 5. Okay, so tell me where you are, 0 to 5 on factoring. There will be zeros, I promise. Okay. 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 Please let me know. Like if you really are a 0 and you held up a 5 just to be okay, please let me know. Because what I'm hearing you say is that you're reasonably comfortable and I'm not talking another language. If you aren't sure how to factor, let me know and I'll send you the videos. Okay. Okay, our next one. Okay, where's my graph? There's my graph, okay. So, down here in the corner is the graph of this function. So down here in the corner is my graph, okay? We're only going to, we're only talking about the above portion of this because we've got the square roots, okay? This is a function because we've got the square root. Now, if we completed this, and we had a circle, then it's no longer a function. But this is a function because it passes the vertical line test. We have a very limited domain in between here. We don't have a very big domain for this particular one. Okay, our domain is the square root of negative 10 to positive 10. That's our entire domain. Okay, our range only goes up to this point right here. I don't think it's 3, but whatever point that is right there is where our range is. It goes from 0 to our height up here. We're going to set this equal to 0 and we're going to solve it. And the way that we set this equal to 0, and the way that we solve this, is we square both sides. So my first step in this is I've got 10 minus x squared equals 0. So I am going to square this side, and then I'm going to square this side. When I square something that's inside a square root, what am I left with after I've squared it? What's inside the square root? So I'm left with 10 minus x squared. What is 0 squared? 0. Okay? Okay. Now, probably what I would do in this situation is I would add x squared to both sides. That's probably what I would do. And then I would be left with 10 equals x squared. So I just added x squared to both sides. However, I know if you were in my 131 class, I said to always keep your variable on the left. So I would subtract 10 from both sides. And then I would have negative x squared equals negative 10. Then I would divide by negative 1. And I would have x squared equals 10. At this point, when I have x squared equals 10, when I take the square root of both sides, so I'm going to take the square root of this side, what do I have to put in front of that square root of 10? Positive and negative. Okay, I have to put positive and negative. Okay, so my x value is positive square root of 10 and negative square root of 10. Okay, so that's how I get this point right here, and it's how I get that point right there. Positive and negative square root of 10. Okay, one more 0 we're going to find. Are we ready? Can I move off the screen? 1 second. I'm good. I got all the seconds in the world. Can I go? Okay. So this is the last one that we're going to find zeros for. And this is a rational function. And rational means that we've got a variable inside some fractions. Okay, so we have a numerator, we have a denominator. We've got a variable in the denominator, and we're still setting it equal to 0. Okay? I need to get rid of my t plus 5. I need to get rid of my t plus 5. Now, can anyone look at this? And now we're finding zeros, but can anybody look at this and tell me what my domain, what is excluded from my domain on this one? What can t not be in my domain? Negative 5. I cannot have negative 5 because negative 5 makes my denominator 0. That's what I can't have. Okay, so what I'm going to do here is I'm setting the whole thing equal to 0, and to find my x-intercepts, I am going to multiply both sides by t plus 5. Okay, so the first thing that I'm going to do here, so I'm going to multiply this side times t plus 5, and I'm going to multiply this side. Okay, now when I multiply 0 times t plus 5, what am I left with? 0. Okay? When I multiply the side on the left times t plus 5, my t plus 5s cancel out. So I'm actually left with just my numerator. I'm left with just my numerator. And when we do rational functions, you'll see to find your x-intercept, you just have to set the numerator equal to 0. Okay? So at this point, I add 3 to both sides. Okay? So my 0 for this one is 3 over 2. It crosses the x-axis in between 1 and 2. Okay? Now, we aren't graphing just yet. I just like to show you the graphs so that you can be aware of them. I like to show you the graphs so you can be aware of them. Okay, before we do anything else, stand up and kind of stretch for a minute, kind of get your brain going. Come on, stand up, stand up, stand up, stand up. We got to move get our blood flowing again, because you need to hear the next 20 minutes worth of stuff that I say, and sometimes about noon we're like, I need to eat lunch, I got to do my quiz 0 with Alicia. I'm just going to I had another class earlier. Okay, cool. Here we go. We are going to talk about some terminology. And this is a reasonable graph to have a picture of. A reasonable graph to have a picture of. We talked briefly about slope with our linear stuff. We don't do a ton of stuff with linear equations in this class. But I want you to think about decreasing and increasing and constant functions similar to the way that we talk about slope. So think about the stock market, or think about your weight. Okay, if you are losing weight or decreasing in weight or decreasing your money, you're going down like this. This is an interval where we're going down. Think about that similar to the way that we think about slope. When things do not change and they are constant, they kind of flatline. When you are not making money and you are not losing money in the stock market, your money stays exactly the same over time. When you are not gaining weight or losing weight, you stay exactly the same. That is constant. Okay? When I am increasing in weight or in money, I go up. Now, we're going to talk about intervals and when our graph is increasing and decreasing. When I'm talking about intervals, the only values I'm talking about are x. It doesn't matter what my y values are. I only care about what my x values are. So this is an important, important thing to remember is when I'm talking about decreasing constant and increasing variables, I'm only looking at my input. So a lot of times when I'm looking at a graph, I will write down those points so that I can physically look at what only my x is. So that's an important thing to look at when we're doing this. Okay, here's another definition page. Okay, if my function is increasing over an interval, my slope, it looks like my slope is increasing, like I have a positive slope. Okay, when a function is decreasing, it looks like I have a negative slope. When my function is constant, it looks like I have a 0 slope. Okay, so I'm going to write that. Now, it's not slope. It's not the same thing as slope. But I think it helps for us to think about it that way sometimes. Okay, so when it's increasing, it looks like a positive slope. Decreasing looks like a negative slope. Constant looks like a 0 slope. That's a horizontal line. Okay. Can I go off this slide? Okay. Okay. So, let's look at this first one. Now, if I took this graph and I pulled it straight, okay, if I just kind of pulled it, and I'm going all this way, what kind of slope does that look like? Increasing. Okay, this kind of looks like a positive slope. Okay, so this one right here, I am increasing the entire time. My slope here is increasing from negative infinity to infinity. Okay? The entire time I'm increasing. I'm increasing. Now, pay attention to these points right here. Do you see this point? Negative 1, 2. 1, negative 2. Okay? The only thing I care about when I'm talking about increasing and decreasing and constant is the x value. So I'm only going to pay attention to this negative 1, and I'm only going to pay attention to this positive 1. Don't worry about increasing and decreasing. Don't worry about your y values. When in doubt, go with the x. When do we definitely go with y? What are we focusing on when we go with y? Range. Good. Excellent. Range. Okay? So, this first one, when I start right here, and I go to that point right there, am I increasing or decreasing what I have highlighted? I'm increasing. What number starts down here? Or way down here, negative infinity. So I am increasing from negative infinity to what value? Excellent. Excellent. And I'm going to use parentheses on increasing and decreasing values. Okay? So now I'm going to erase this. Okay. What's happening from here to here? What's happening? Decreasing. So I am decreasing. I'm looking at my y values. What interval am I decreasing? Okay, now somebody said 2 to 2. Okay, 2 to negative 2, that is your y values. When I'm talking about intervals, I want to know what my x values are. So I'm actually doing negative 1 to 1. That's what I want to focus on. So when I am decreasing in this one, I am decreasing from the x value of negative 1 to the y value of positive 1. That's why those are important. That's why I only want to know about those x values. Okay. Now my last one starts here and goes all the way. So I'm increasing again. Where did I start? What was my x value where I started? 1. And how far did I go? Infinity. Okay? So when we're talking about constant increasing and decreasing intervals, we are talking about my x value. I want you guys to try this one right here. Try my last one. Don't worry about what it says. This is a piecewise function. Don't worry about what the function actually is. I want you to tell me the intervals. So what's happening here and what is the interval? What's happening here and what is the interval? And what's happening here and what's the interval? pay attention to those points. Okay, so that's 0, 1, and 2, 1. Okay, what interval are you increasing? What interval are you increasing? We started way down here. Good. So I'm increasing from negative infinity to 0. Okay. When am I constant? You got it. 0 to 2. That's when I'm constant. That's when I've made no money. I have lost no weight. Okay. When am I decreasing? 2, 2. Excellent. Got it. Good job. Okay, more definitions. Okay. When we talk about parabolas are your x squared. You're going to have a maximum and you're going to have a minimum when we talk about that. When we're talking about other types of graph, you could have a relative minimum and a relative maximum. So you're really looking at where is the graph at its highest point and where is its graph at its lowest point. Okay? So your relative minimum is your lowest point. Okay? Your relative maximum is your highest. And it's where your graph changes direction. Okay? It's where your graph changes direction. Okay? It's where your graph changes direction. That's an important thing to know. Where your graph changes direction. Okay? So, here, in this particular graph right here, there's relative minimums. Those are low points. Here's relative maximum, your high points. Do you see how my graph is changing directions? Okay, that's what's happening. My graph changes directions. Now, this goes on to infinity, but that doesn't matter. I'm not talking about going on to infinity and negative infinity. What I'm talking about is where the graph changes direction. Where the graph changes direction. Okay, I want to talk about even and odd functions super quick because I want you to at least be able to try it some before your homework this week. And so let me talk about it super quick. This is a good slide to go ahead and take a picture of. Do you remember when we talked about symmetrical to the y-axis, symmetrical to the x-axis, and symmetrical to the origin? Okay, we talked about that, I guess, probably a week ago. Okay? If you're going to take a picture of this, I'd wait until I write on it. Something is even. A function is even when it is symmetrical to the y-axis. Okay? A function is even when it's symmetrical to the y-axis. And that means when you replace x with negative x, and you get the same thing. Okay? When you replace x with negative x, and you get the same thing, then it's symmetrical to the y-axis and it's even. For something to be an odd function, it is symmetrical to the origin. Okay, it's symmetrical to the origin. And that means we replace, for it to be odd, we replace y with negative y and x with negative x. Okay? So we're really not doing anything new when we start talking about even and odd functions. We're just talking about symmetrical to the y-axis and symmetrical to the origin. Now, we also had symmetrical to the x-axis. But when something was symmetrical to the x-axis, it wasn't a function. Okay? For something to be symmetrical to the x-axis, it had to fold on top of the x-axis, and y's had to be the same. Or y's had to be opposite. And when that happened, we didn't have a function. So now we're talking about even and odd functions. And so when we talk about even and odd functions, we're only talking about symmetry to the y-axis and symmetry to the origin. So I want you to look at these two graphs. This is what you should take a picture of if you're going to take a picture of something. So oops. We got our pictures. I see a couple phones. Okay. So here, this is an odd function. Now, you're going to have to show this algebraically, but I want you to look at it graphically also. This is an odd function because it's symmetrical to the origin. That's an even function because it's symmetrical to the y-axis. Okay? All even functions are going to be raised to an even power. Now, I'm not saying all functions raised to an even power are even functions. I'm saying all even functions must be raised to an even power. There are plenty of functions whose highest coefficient is even that are not an even function. But if you've got something that says h of x equals x squared plus 1, you don't even need to test to see if it's an odd function. You only need to test to see if it's even. Okay? Odd functions, if your exponent is raised to an odd power, you only need to test and see if it's odd. You don't have to test. You automatically know this one's not even because you've got an odd exponent. But please don't hear me say that everything that has an odd exponent is an odd function, because it's not. Okay? Work on homework this weekend. Focus on those odds. I'll see you on Tuesday.